Hello, my name is Philip Archuleta, and today I will be presenting the Cam2 Crowdsourcing Research Group's poster for the Spring 2020 Undergraduate Research Conference at Purdue University. Our topic is detecting bias in image datasets by utilizing crowdsourcing, and contributing members are listed at the top of the poster directly under the title. Image classification algorithms generally rely on training data in the form of image datasets to learn how to classify. This is described in Figure 1. If a training set is biased, say all airplanes in a dataset are facing left, the algorithm may incorporate that bias into its definition of the object. For instance, in this given example, an algorithm may only consider airplanes to be airplanes if they are facing left. Figure 2 shows this concept with another example, identifying wolves and huskies. The training data showed all wolves in snowy environments, and therefore the algorithm always classified images as a wolf if the background was white. Our objective is to detect and report biased attributes in image datasets by utilizing the power of crowdsourcing through a Django-based web game, ensuring images given to crowd workers are representative of the dataset as a whole. If successful, this has huge ramifications. Training data can be better constructed for image identification algorithms, and therefore more accurate and more precise algorithms result. To do this, we will first reduce some large given dataset to a smaller, yet still representative one, as shown in Figure 3. I'll be coming back to this step in more detail later, however let me first explain why the original large dataset cannot just be used instead. Crowdsourcing requires us to pay each of the crowd workers in addition to having to wait for them to complete their tasks. It would simply require too many resources to analyze the entirety of the initial dataset. After this step, this smaller dataset will be gamified by our website into 3 unique tasks, each completed by non-overlapping groups of crowd workers as shown in Figure 4. The first phase of the game will involve crowd workers generating questions and answers describing the given images in the frame or iteration of the task. The second phase will involve crowd workers answering the questions developed in the first phase once again, and this is for redundancy reduction. The third phase will involve crowd workers defining the biases, essentially determining if the results of the previous 2 phases effectively describe non-essential elements of the object in the image and are in fact a bias. In previous semesters, the crowdsourcing team has concluded that crowdsourcing may be used to identify injected and non-injected biases in small datasets. For the injected or intentionally placed biases, crowd workers from Amazon Mechanical Turk identified these biases with 100% coverage. For the non-injected biases, out of 21 expert-identified biases, with us being the experts, crowd workers from Amazon Mechanical Turk identified 15 of them, or 71.4%, taking random samples of the initial dataset. These random samples are not necessarily representative of the initial dataset, however, the exact issue that the team is currently trying to correct. At present, the team is working on determining and implementing the best method to refine a large dataset into a smaller, yet still representative one, as shown in Figure 3. We are exploring hierarchical clustering, K-meteoroid clustering, and a combined RGB free channel mean and edge extraction method to classify similar images. Each classification cluster will have 3 images pulled from it for each frame, or iteration, of each of the phases in Figure 4. In the case that a cluster is smaller than 3 images, the most similar additional cluster will provide the needed images. This is shown in Figure 5. We do not yet have results for this, but once we do and determine the most optimal method, we will be ready to conduct the experiment as a whole. Acknowledgement goes to Professor Liu, the Cam2 director, Professor Yin, the Computer Science Department's crowdsourcing advisor, and the VIP program at Purdue University. Thank you.